NASA has released images of a never-before-seen phenomenon where a star named Betelgeuse blew its top off and ejected a gigantic portion of its surface mass. The event is known as surface mass ejection, SME, and according to the space agency, the ejection was 400 billion times the mass of an ordinary solar flare from our Sun. Scientists termed the event as watching stellar evolution in real time. A star blasting off such huge chunks of its physical form has surprised many. The catastrophic explosion of this super-red giant is upsetting a lot of what we know in the universe. Why did Betelgeuse blow off its top? How will that affect the universe? Let's find out. Constellations are made up of many stars and are arranged in accordance with mythology and legends. They are still used for navigation today. One such star is Betelgeuse, which is among the largest and brightest stars in our night sky. The brilliant ruby-red glittering star known as Betelgeuse is located in the upper right shoulder of the winter constellation Orion the Hunter. When viewed attentively, though, astronomers recognize it as a seething monster with a 400-day-long heartbeat of regular pulsations. Because of its dismal orange-red color, Betelgeuse is easily identified. It's ideal for convincing doubters that stars do in fact have different colors. It is also known as Alpha Orionis, and it is the second brightest star in the constellation after the blue supergiant Rigel. Betelgeuse is an intriguing object for star studies and observations due to its variable nature as well as its odd name. Frequently, stars with the name Alpha are the brightest stars in their constellations, even though Rigel, Orion's other bright star, is brighter. Betelgeuse is Alpha Orionis due to its name, brightness, size, and reddish hue. It is also one of the most well-known stars. It's noteworthy to note that this star served as the model for both the character and the movie Betelgeuse. Betelgeuse is the seventh brightest star that can be seen from most of North America, Europe, and Canada, and it is the 10th brightest star overall in the sky. Earth is relatively close to Betelgeuse. Astronomers are unable to pinpoint Betelgeuse's exact distance from Earth, although they believe it to be between 430 and 724 light-years away. Betelgeuse is the brightest red supergiant star and is closest to Earth in our galaxy. There are just 200 red supergiant stars that have been identified. The Sun has a radius that is around 764 times larger than Betelgeuse. If this star replaced our Sun in the solar system, it would reach past the asteroid belt and even beyond Jupiter. This suggests the Earth, Mars, Venus, and Mercury would all be completely absorbed. Betelgeuse is 16.5 times as massive as the Sun. This supergiant has 126,000 solar luminosities and is visible from 548 light-years away. This star has a surface temperature of 3,600 Kelvin, making it cooler than the Sun. Only about 13% of Betelgeuse's radiant energy is visible light. If human eyes could see light at all wavelengths, Betelgeuse would overtake Sirius as the brightest star in our night sky. Betelgeuse loses about one solar mass every 10,000 years. The red star is surrounded by a nebula because this material is being ejected unevenly from the star in all directions. A cloud of material 250 times larger than this star surrounds Betelgeuse. The size of this nebula is also thought to be 30 astronomical units, or 30 times the Sun-Earth distance. The Sun and Neptune, the furthest planet in the solar system, are separated by this distance. Our solar system's Sun regularly ejects mass into space, which is known as solar flares. However, the Sun only exhales tiny fragments of its outer atmosphere, known as the corona, giving the phenomenon the name coronal mass ejection, CME. As a result, coronal mass ejections and surface mass ejections can occur at separate times. When a star ejects a portion of its unstable outer atmosphere, it causes a CME, known as the corona. CMEs from our solar system occur very frequently and can have an impact on Earth and its inhabitants. CMEs can travel more than 1,800 miles per second while ejecting magnetic fields and plasma into space, occasionally allowing them to arrive on Earth in a matter of hours. A CME can disrupt and harm Earth's satellites and power infrastructures when it occurs on the side of the Sun that faces the planet, occasionally putting astronauts in orbit in danger. The recent discovery shed light on the exceptional cause of Betelgeuse's dimming in 2019. The material that the star ejected exploded into space, cooled, and produced a cloud of cosmic dust that hid Betelgeuse's brightness from Earth-based observers. Additionally, Betelgeuse's renowned steady pulsing pattern has been altered. The CME on Betelgeuse is unusual because it released 400 billion times more mass than a typical CME, which caused the star to tremble like a dish of gelatin desserts, according to a NASA news release. Andrea Dupree, an astronomer at the Center for Astrophysics, suggests that the star's internal convection cells may be in disorder while the photosphere, which is what we perceive as the star's surface, struggles to reconstruct itself. Astronomers have been tracking the star's constant pattern for the past 200 years, yet it no longer exists. All red giants, including Betelgeuse, are perishing, and being able to observe this process will allow researchers to learn a lot about the evolution of stars. The majority of stars in the cosmos are powered by nuclear fusion, which eventually burns out and causes a star to undergo a series of intriguing stellar changes before it finally perishes. When a star is born, it is made of hydrogen, which under the force of gravity fuses together in the star's core to create helium in a nuclear explosion. A lot of heat and light energy is typically released during the fusion process. This energy travels to the star's surface and is released as a photon into space. As the star ages, its primary fuel, hydrogen, runs out, and helium starts to combine with carbon to form carbon. After the helium is used up, neon will eventually combine with carbon to form iron. When this happens, the fusion of neon with iron absorbs energy instead of releasing it. Because there is nothing to oppose the star's very powerful gravity when iron begins to fuse, the star collapses in on itself, giving rise to a supernova explosion. A supernova, one of nature's most powerful forces, can generate more energy than 10 billion suns. Stars change hue during the course of their existence, from the youngest hottest blue forms to the older cooler red varieties, depending on what stage of their stellar evolution they have reached. The Greek scientist Ptolemy, 90 to 168 AD, strangely referred to Betelgeuse's color as having a ruddiness, yet 3 centuries earlier, Chinese astronomers had characterized the star as having a yellow appearance, possibly implying that Betelgeuse was formerly a yellow supergiant. Larger stars frequently burn through their hydrogen faster and die off sooner. Despite being only roughly 10 million years old, Betelgeuse is certainly nearing the end of its lifespan. Our Sun, on the other hand, is still in its prime at approximately 5 billion years old. Furthermore, because Betelgeuse is nearing the end of its life, it's possible that a supernova will occur soon. Betelgeuse undergoes 2 dimming and brightening cycles, the second of which occurs approximately every 5 years and lasts around 100 days. The star's outer shell is thought to expand and contract during this cycle, changing the star's circumference and average temperature in accordance with each step of the cycle. Astronomers may gain a better understanding of how red stars lose mass in their last days before exploding in a bright supernova from Betelgeuse's explosion. As Dupree notes, we've never before seen a huge mass ejection on the surface of a star. We are left with something going on that we don't completely understand. It's a totally new phenomenon that we can observe directly and resolve surface details with Hubble. We're watching stellar evolution in real time, but it's unclear whether this development portends Betelgeuse's impending supernova explosion because the results are so unusual. NASA has issued a warning that Betelgeuse may not have reached the end of its life. Even if it has, cosmic time is long, and red supergiants die quickly by comparison. According to NASA, Betelgeuse will explode in the next 100,000 years. Betelgeuse has been the focus of intense studies since the 1st century BCE. More recently, a scientist named Serafina Nance and her team sought to determine the potential timing of supernova explosions of red supergiants like Betelgeuse. Using Betelgeuse as a model, they ran multiple simulations and contrasted their findings with field observations. One question they investigated is why Betelgeuse dims suddenly and out of sync with its regular cycle, even though it likely won't explode for another 100,000 years. Betelgeuse was evicted from its home in the Orion OB1 association, which includes the stars in Orion's belt, and has been seen moving through the interstellar medium at a speed of 30 kilometers per second. This movement has produced a bow shock more than 4 light-years wide. By mid-February 2020, Betelgeuse had lost about 3 times its brightness, dropping from magnitude 0.5 to 1.7 after starting to decline sharply in October 2019. By February 17, 2020, its brightness had stabilized, and the star began brightening once again. However, Betelgeuse appeared to have stopped dimming entirely just 5 days later, marking the end of the dimming episode. On February 24, 2020, there were no significant changes in the infrared spectrum, suggesting the recent fading wasn't related to an anticipated core collapse. Another study that same day concluded the dimming was likely caused by large-grain circumstellar dust rather than dust absorption. The fading appeared to be due to large star spots. Further analysis revealed a dramatic increase in Betelgeuse's brightness between May and August of 2020. Observations made in June and July of that year with the StereoA satellite showed the star had dimmed by 0.5 magnitude, surprising astronomers since the maximum and subsequent minimum were expected to occur in August and September 2020, and April 2021, respectively. Betelgeuse's brightness is known to fluctuate wildly, making predictions difficult. This fading suggested that another dimming event could happen sooner than expected. Astronomers discovered a second dust cloud coming from Betelgeuse, linked to the star's considerable dimming. A study conducted using the Hubble Space Telescope in 2022 suggested this dust may have been created by a surface mass ejection, with the material cooling and compacting into the fading dust cloud. The material was ejected millions of kilometers away, where it cooled and created a dust cloud that obscured the star from Earth. The fading event, which began in late 2019, lasted for several months and was visible even to backyard observers. Even more remarkable was the disappearance of Betelgeuse's 400-day pulsation rate, a cycle astronomers had been tracking for nearly 200 years. This disruption revealed the extent of the star's blast. Astronomers believe the star is slowly rebuilding its strength, regenerating its photosphere, although the disturbance has thrown off its normal cycle, causing the interior to vibrate like a bell after a massive stellar surface mass ejection, a phenomenon never observed before. While no one knows exactly when Betelgeuse will go supernova, it could happen tomorrow or a million years from now. The explosion won't threaten life on Earth because Betelgeuse is too distant, more than 10 times farther than the minimum safe distance of 50 light-years. Instead, when Betelgeuse does explode, everyone on Earth will be treated to the spectacular sight of a very bright star in the night sky. Since Betelgeuse is so close, astronomers will have a unique opportunity to study the star's supernova when it happens. Betelgeuse is currently not visible in the night sky, and even if it had gone supernova over 500 years ago, its light has yet to reach us. Scientists are excited to witness Betelgeuse's potential explosion and recovery. In the meantime, NASA's James Webb Space Telescope may be able to track the star's ejected material, while the Hubble Space Telescope continues to study Betelgeuse.